Tonight we're going to continue our discussion on finding the volume of prisms. Last night we focused on rectangular prisms, and tonight we're going to focus on triangular prisms. You remember, a triangular prism will have two triangular bases, and the rest of the faces of the prism will be rectangles. So our objective is I can find the volume of a triangular prism. Tonight I'm going to try to build why we can do area of the base times the height to figure out the volume of a triangular prism. So let's run through an example. This is from the New York State mod, and I kind of like how they build the formula for the volume of a triangular prism, so I thought, well, why not share it with you. It says, will the formula for the volume of a rectangular prism, where our volume last night we discussed area of the base times the height, also work for triangular prisms? The volume of a solid is the quantity given by the number of unit cubes needed to fill the solid. Most solids, like rocks, baseballs, people, can't be filled with unit cubes or assembled from unit cubes because we'd have to break those cubes in half. We'd have to round out the corners of those cubes. Yet such solids still have a volume. Fortunately, we do not need to assemble solids from unit cubes in order to calculate their volume. One of the first interesting examples of a solid that cannot be assembled from cubes but whose volume can still be calculated from a formula is a right triangular prism. So let's go ahead and build the formulas for finding the volume of a right triangular prism. It says, what's the area of the square pictured to the right? It's actually pictured below. We're going to show some work. So to find the area of this square, we can do side squared, or base times height. So this is 1, 2, 3, 4, 5, 6 units by 1, 2, 3, 4, 5, 6 units. It's a square. So the area of that square would be base times height. Quick little review of that. 6 units times 6 units would be 36 square units. That makes sense. If we count up all the squares that make up the figure, that's all that area is. There's 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Shoot! There sure are 36 squares that make up that figure. Then it says draw a diagonal joining the two given points, then darken the grid lines within the lower triangular region. What is the area of that triangular region? Show your work. Okay, I don't have a straight edge, so oops, my line is not going to be beautiful here. You're just going to have to handle that. You should use a straight edge so your line can be beautiful. And then it says just darken in that lower region. Then we'll find the area of that lower region. Well, hopefully you see that this triangle, this lower triangle, is really half of the square. So the area of our triangle would be 1/2 times your base times your height. The lower level here is literally half the area of the entire square. So that would be 1/2 times 6 times 6. That would be 1/2 of 36, or 18. And if we tried counting up our squares, we would get to 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, because I have to put those half squares together the half squares together to make a full square. All right, so that's the area of our triangular region. All right, great. How is this going to help us with volume? So now it says, what is the volume of the right prism pictured here? So the volume, well, we know the area of the base times the height gives us our volume. So this was a 6 by 6 base. So the area of our base would 6 times 6 times, what's the height? Oh gosh, it's just 1 unit tall. All right, 6 times 6 is 36 times 1. That would be 36. Now it's 36 cubes. Now we're talking about a volume. 36 cubes fill up this space. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. It's now 36 cubes making up this figure. So that's why we're now talking about volume. We now have a height to it. All right. Now, if we draw that same diagonal, we could find the volume of the triangular prism. So I'm going to now draw in that same diagonal, and hopefully you're saying to yourself, well, the volume of the entire rectangular prism is 36. The volume of half of that will be 18. So the volume of our triangular prism should be 18. So we would want to count up full cubes and then put together any half cubes. So let's count up our full cubes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Those two together would be 16. Those two together would be 17. Those two together would be 18. So the volume of this triangular prism will be 18 units cubed. It'll take 18 cubes to make up that triangular prism. Let's go ahead and find the volume using area of the base times the height and make sure it is 18. So this would be for our triangular prism. Area of the base is 1/2 times base times height, and then times the height of the prism. This is the height of the triangle. This is the base of the triangle. That's why this can get a little bit complicated. We're talking about two different heights here. So for our triangle, the base is 1, 2, 3, 4, 5, 6. So it's 1/2 times 6. The height of our triangle is 1, 2, 3, 4, 5, 6. And then we have the height of our prism. Well, our prism, if we look how tall our prism is, it's only 1 unit tall. That prism is just 1 unit tall. So that's why the height of the prism is 1. So 1/2 times 36 times 1. Half of 36 is 18. 18 times 1 high is 18 cubes will fill up that figure. All right. So we drew the same diagonal of the square base as done above. We darkened in the grid line on the lower right triangle. And we found the volume of that triangular prism. So what about if we had a triangular prism that was more than 1 unit tall? All right. What if we took that and we made it 5 units tall? Okay? So if we stacked 5 identical triangular prisms, one on top of the other, what would be the entire volume? Well, we figured out the bottom layer here, we know took us 18 cubes to fill that. The volume here would be 18. 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 So really, if you just take 18 times 1, 2, 3, 4, 5, 18 times 5 will give me my volume of the overall triangular prism here. And 18 times 5 is 90. So it would take 90 cubes to fill up this triangular prism. Let's just go ahead and make sure with area of the base times the height, so our volume would equal the area of the base times the height. Area of our base will be our area of our triangle. It's a triangular base. So you find the area of that triangle. And then you just multiply it by how tall your prism is. And then times the height of your prism. All right. So the area of our triangle will be 1/2 times the base of the triangle times the height of the triangle. I'll put a big B here. Okay, this is talking about the area of the triangle. And then times the height of the prism. So this would be 1/2 times, we've been working out this problem on several slides at this point. The base is 1, 2, 3, 4, 5, 6, times the height of that triangle is 1, 2, 3, 4, 5, 6. And we've been working this out all day. Half of 36 is 18. Then you have to multiply it by the height of the prism. Well, the prism is 1, 2, 3, 4, 5 high. So 18 times 5 will give us 90 cubic units. Makes up that triangular prism. All right, let's see if I did an additional example here now, not broken down by cubes. So what the bottom line of this entire video, I feel like it's a little long-winded, I'm going to be honest with you, but to find the volume of a triangular prism, you take the area of the base triangle times the height of the prism. That can give you the overall volume. And the only reason I went through this whole example with all these cubes was try to prove why, if we physically looked at why it would be. Let's see if I can do another example. Oh, of course I did. Find the volume of the right triangular prism shown in the diagram using the formula. Area of the base times the height. So for the triangular prism, your base is always a triangle. So we're going to take the area of the triangle times the height of the prism. That will give us the volume. So the area of a triangle, if I look at my triangular face, my base, so it's 1/2 times the base of the triangle times the height of the triangle. And then I'll multiply that by the height of the prism. So if I look at the length of the base of my triangle, it's 4. So that's 1/2 times 4. And the height of my triangle is 1/2. And then the height of the actual prism is how tall it would go if we sat this up on the triangular face. How deep or how tall does our prism go? So the height of our prism is 6.5. So first of all, now I can multiply this out. Half of 4 is 2 times 1/2 times 6.5. Half of 2 is 1. 1 times 6.5. So the volume of this triangular prism is 6.5 meters cubed. Meters times meters times meters is meters cubed. Meters times meters times meters. Volume is how many cubes would fill up that space. It would be 6.5. Hopefully that is just a little, jump into how to find the area, or I'm sorry, how to find the volume of a triangular prism. I'm not thrilled with this video, but I don't believe in more than one take, so oh well. I hope that at least gives you an overview of finding the volume of a triangular prism. You just take the area of that base triangle times the height of the prism will give you the volume.